Welcome to this video from In 28 Minutes. Thanks for helping us provide awesome learning experiences to more than 300,000 learners across multiple platforms, Udemy, Safari, and Pact. Let's welcome our lead instructor, Rangarao Karanam. Welcome to this section where we would be introducing the Spring Framework to you. If you have experience working with the Spring Framework, I would recommend you to skip this section and move on to the next section on Spring Boot. However, if you are new or if you are not sure about your Spring concepts like dependency injection, inversion of control, tight coupling and things like that, I would recommend you to spend some time doing this section. In this section, we'll help you how to set up a simple Spring project. We'll help you understand the concepts of tight coupling, loose coupling, dependency injection, inversion of control, and auto wiring. We'll also give you a high-level picture on the Spring world. What are Spring modules? What are Spring projects? And we'll also understand why Spring Framework is so popular. The home folder for this specific section of the course is in our GitHub repository Spring Web Services. The folder is Spring in 10 Steps. If you go down here, you have all the details of the 10 steps and the complete code example as it is at the end of all the 10 steps. Understanding Spring Framework is a key part of becoming a great developer as well as developing great web services. I'll see you in the first video of this section.
Welcome back. One of the most important features of Spring Framework is dependency injection. Spring Framework helps in creating loosely coupled applications. To be able to appreciate dependency injection, you should understand tight coupling and how to create loosely coupled applications. What we'll start with is setting up a simple example to be able to understand tight coupling and also dependency injection. We will use a shortcut to create a Spring project. What we'll do is we'll go to start.spring.io. It's called Spring Initializer. If you do a Google search for Spring Initializer, so if you do a Google search for this Spring Initializer, you should be able to come here directly, or you just type in start.spring.io. Let's create a Spring project using Spring Boot. What we need to do is let's use Maven here. Java is our language, not Kotlin. Let's move to Java. We would want to use Spring Boot. I will use one of the latest versions of Spring Boot. If by the time you're watching the video, there is a released version of 2. something, you can use 2. something as well. So I'm using the snapshot version. You can actually use any version which is greater than Spring Boot 2. So M2 should also be fine. One of the things that you need to do when you create a project is to give it a name. Just like when you create a class, you give it a package name and a class name. When you create a project, you need to give it a group ID and an artifact ID. Let's give a group ID and artifact ID. So I'll call this com.in28minutes.spring.basics, and I'll call this as Spring in 5 steps. We might have a few more steps than 5, but let's just call it Spring in 5 steps. I don't really need to add any dependencies when I create a project with Spring Boot. It would by default create Spring as one of the dependencies for the project. So I don't really need to worry about adding any other dependencies. I can go ahead and click generate project. What would happen when you generate project is a zip is created and it would be downloaded to your downloads folder. What I would want you to do is to unzip the zip. So unzip the archive, put it on some folder on your hard disk. Let's say c:/spring. Generate project, downloads a zip. If you have extracted the zip file to a specific folder, then you are ready to go into Eclipse and start importing that project in. So how do I import the project? It's very simple. All that you need to do is file, import existing Maven projects. So you can type in Maven here. You'd come on existing Maven projects, select existing Maven projects, click next, and then you would need to select the folder where you have copied the zip file to. So you have extracted the zip file to a specific folder, right? So you can either browse through that or copy the path to it and paste it in here. So I've actually put the whole thing in this folder, Spring in 5 steps. So I'm opening that folder up, and now you can see Spring in 5 steps, pom.xml in here. Just select that project, finish. If this is the first time you are working with a Spring Boot project, the import might take a little while. There are a lot of dependencies that it needs to download to set up this project. If everything works fine, at the end of a few minutes, you should be able to see a project like this. So what I see is source main Java. This is where the Java code will be written. Source main resources. This is where all your application properties will be residing. So test Java. This is where your tests will be written. And you can also see all the different Maven dependencies which are present in here. The great thing about creating a Spring Boot project is Spring is directly added in as a dependency. So you can see there's Spring context here, Spring beans. So all these are already added in as your Maven dependencies. So you don't really need to set up a new project where I would add Spring as a dependency. All this kind of stuff are already made available to you, and that's the reason why we are using Spring Boot. So you can see here, you can see Spring Core, Spring Context, Spring Beans. All of these are already available to you to make use of. What we did until now is we used Spring Boot to set up a simple Spring example. There is not a lot of things that are there right now. So if you go ahead and run this, actually, if you say Spring in 5 steps application, go here and say right click, run as Java application. What this will do is this will launch up a simple Spring context. You don't really need to worry about it right now. We will understand what a Spring context is and all that a little later. But you can see that this program successfully runs and prints something on the console. That's sufficient for this step. So in this step, what we wanted to do was to set up a simple example for Spring.
If you are familiar with programming, you know what a search is, right? So you're given a number, you're given an array, you try to find the number in an array. For example, here, I would want to search this array for this number. A binary search is a specific search algorithm which expects the array to be sorted. For binary search, it's not okay if I send an array like this. What I would need to do is to sort the array, and then I would be able to search through that. In this step, we'll set up a simple example using Spring Boot to be able to do a binary search. The objective is to understand the concepts of tight coupling and dependency injection. In the previous step, we used Spring Boot to create a simple application, Spring in 5 steps application, and we were able to run it as a Java application. Now we would want to add the logic of binary search to this example. So I'll create a new class, Control N or Command N, and I would want to say new class, and next I would want to call this class as binary search IMPL. I will not use an interface for now, but I'll continue using binary search IMPL, and let's go and say finish. The first step of binary search is sorting an array. Binary search expects a sorted array. When I want to use binary search on an array, first thing is I would need to sort the array, and next I would want to search the array, and after that I would need to return the result. The result is typically the index. So if the element is present in, let's say, position 3, then I return 3 back. How do I design a method like that? One of the things that you need to remember is we are not really going to implement the entire logic for binary search. I would just implement high-level algorithm, if you can call it that way, just to get you understanding about tight coupling and loose coupling. Let's get started with a simple method. So now I would want to create a method to do a binary search. How would the definition for that would be looking like? Public int. So I would want to return the index back. So it's an int. I would want to call this method as binary search. The inputs for a binary search, as we discussed earlier, are an array. So I'll pass in an integer array. I'll call this numbers and the number to search for. So the first step of binary search would be to do sorting, right? So first you would implement all the sorting logic here, implement sorting logic here, and then you would actually implement the search logic here. And after searching the array using binary search, you would return the index of the result back. So let's say the index where it is found is 3. I would return 3 back. I'm just returning 3 to make the compiler happy. This is how your binary search algorithm would look like, right? So you just need to implement your sorting logic here, you would implement the search logic here, and then you would return a 3 back. Now I would want to use this binary search algorithm. One thing to remember is this is just a dummy algorithm. It's not really a real thing. So all that I would need to do to be able to use that here. So I'm opening up the Spring in 5 steps application class, which is in directly here. So I'm going here. I would want to use the binary search IMPL. So I would need to create an instance of it. So binary search IMPL, binary search is equal to new binary search IMPL. And
I would want to do a binary search. So I can say binary search dot binary search of, I would need to pass in an array. So I'll create an array directly here. So new int with, let's say, a few numbers, 12, 4. I'm having a little bit of trouble with the auto thing. So let's type in 3 for now. Let's just have 2 numbers in the array and say save. And now I can go ahead and make it 12 and 4. So what we have created in here is we are sending in array, and this is the number we would want to search for in the array. And let's do a sys out of this, or what we can do is we'll take it to a variable. So int result is equal to this, and we print the result. Actually, the result is not really important. What we want to try to understand here is the concept of loose coupling. So let's run the JUnit test. Oh, actually it's a Java application. So right click, run as Java application. You would see that at the start 3 is printed because that's the result of this specific thing, because that's what is written back from here. That's cool. Now we have implemented a simple dummy method for doing a binary search. Let's say this is using the sorting logic is implemented by using bubble sort algorithm. You don't need to really worry about what the bubble sort algorithm is. It's one of the algorithms. So let's call it algorithm 1 or bubble sort algorithm. So let's say I have bubble sort algorithm which is used in here. This logic of binary search is tightly coupled to the bubble sort algorithm. What I mean by that is that if I want to change the algorithm, then I would need to change the code of the binary search. That's what tight coupling means. This binary search IMPL is tightly coupled to the bubble sort algorithm which is present in here. And that's not really good. Let's say over a period of time, things evolved and there's a new sorting algorithm. Let's just take quicksort for an example. I'd want to switch this to quicksort. Then I would need to change this piece of code to be able to use quicksort. Think of another scenario. So sometimes I want to use bubble sort, sometimes I would want to use quicksort. How do I separate them out? How do I make them loosely coupled? One of the things that we can do is we can actually start implementing a algorithm for bubble sort outside. So let's start with a simple thing. So let's start with taking bubble sort outside this search. So how do I do that? What I would do is actually start with creating a new class. So I'll start with creating a new class. I'll call this bubble sort algorithm. Bubble sort algorithm. Let's say this is the one which can do the sorting. So now I would say public. A sort algorithm takes an array of numbers and returns an array of numbers. So I'll say int and sort int numbers. This is what a sort algorithm does. You would put all the logic in here. So logic for bubble sort, and then you can return the sorted numbers back. One thing which is important for you to understand here is that we are not really implementing the logic. Let's assume that the logic for bubble sort is implemented in here and we are returning numbers back. So now this particular program has the capability to sort. So what I can do now is I can use bubble sort algorithm here. So bubble sort algorithm, so I'll call this bubble sort algorithm is equal to new bubble sort algorithm. Instead of, and to do the sorting, what I can do is say bubble sort algorithm dot sort numbers, and I would actually receive the result. So I would call it int sorted numbers is equal to bubble sort algorithm dot sort. So now this sorting logic is moved out. I can just implement the binary search logic here and return the index back. So the sorting algorithm of bubble sort is moved out. That's cool. Bubble sort is outside the ambit of binary search. So if anytime there is a change in logic of bubble sort, all that I need to do is change the logic here. Nothing else needs to change. I have not solved the problem of being able to change the sort algorithm dynamically. So I would want to be able to run this binary search different sorting algorithm. In a way, this is better because this is now the sorting algorithm is now moved out. But still, I have the problem of not being able to change the algorithm. So let's say I quickly create a quick sort algorithm. So I'll just Control C, Control V, and I have a quick sort algorithm. Quick sort. So I'm not going to change anything in here. I'll just leave the logic as it is, and just let's say the logic for quick sort is what is being implemented in here. So now I would want to be able to switch between quick sort and the bubble sort algorithms dynamically. I would want the search algorithm, the binary search algorithm, to be more loosely coupled. I would want to be able to pass in the sort algorithm in. How do I do that? Think about it. This is more of a Java problem. Just think about it, and we will find the solution for it in the next step. In the previous step, we created two simple algorithms, bubble sort algorithm and quick sort algorithm. And in the binary search, we are currently using the bubble sort algorithm, and we are now searching for a way where I would be able to make the binary search use the algorithm I would want to configure. So right now it's hard coded to use the bubble sort algorithm. How do I make the binary search IMPL use a different algorithm? Like, one way I can do that is just change quicksort here, but that would not serve the purpose because I would not be able to dynamically determine which algorithm to use. I hope you had time to think about the solution for this and you had the solution built in. Okay, let's now go ahead and implement a simple solution for this. The solution obviously is interface. I'll go to bubble sort algorithm and say implements sort algorithm. So right now there is no interface called sort algorithm. We'll create it right now. So I'll say create interface sort algorithm. All that I need to do is control 1 or command 1 if you're on Mac and say create interface sort algorithm, and that's cool. I would want to add a interface. I don't want to extend anything. I think that's cool. Now let's go ahead and finish. The sort algorithm is implemented. I would want to add one method to it. That's this. Now I have the bubble sort algorithm implementing the sort method. Now I can also make the quick sort algorithm implement this interface. So I can say quick sort algorithm implements. Cool, isn't it? Now you have quick sort algorithm and the bubble sort algorithm, both of them implementing the sort algorithm interface. I would want to be able to make the binary search use the algorithm dynamically. So I would want to be able to switch between the algorithms. How do I do that? The way I can do that is by making the binary search IMPL use the interface instead of the implementation. So I'm creating an instance of the sort algorithm in here. Obviously, since it's an instance, I have to make it private. And I'll also create a constructor. So all that you need to do is do a right click source. You can say generate constructor here, or you can say alt shift S or command option S, and you can say generate constructor using fields, and you can select the sort algorithm. And now I have a binary search constructor taking the sort algorithm as the input. What I would now need to do is to switch the program to use this sort algorithm instead of the bubble sort algorithm. So now the program uses sort algorithm. So what I'll do also in here is do a sysout of the algorithm which is being made use of. So I'm doing a sysout here saying sort algorithm. We have changed the binary search IMPL to use the interface. What we are doing in here is we have now separated the binary search IMPL from the sort algorithm it's making use of. You can dynamically decide which algorithm you'd want the binary search IMPL to use. This is basically how you make your code loosely coupled. When you hear people talking about interfaces making the applications loosely coupled, this is what they are talking about. So now I can dynamically supply what I would want to use. So say I would want to use it with bubble sort algorithm. Now I've created a binary search using the bubble sort algorithm, and you would see that when I execute this, I'll just comment this line for now. We'll use this when we actually run Spring context. For now, we are not running anything related to Spring. So let's right click run as Java application. You'd see that it's printing this in the console. What is it printing? Let's take this. The binary search is using what algorithm? It's using the bubble sort algorithm. If I actually want to change, let's say I want to change quicksort, all that I need to do is change it here. So I'm not changing anything in the implementation of binary search. Quicksort algorithm we want to use. So now if I run this right now, what would be the output? Awesome. Quicksort algorithm. What we have done is we have made binary search IMPL independent of the sort algorithm being used. You can create a new algorithm and you can start using binary search IMPL with this. Sort algorithm is a dependency of the binary search. So binary search depends on the sort algorithm. We are making the sort algorithm as a separate dependency, and we are passing it in to the binary search IMPL. I have to still create the instance of binary search IMPL, create an instance of the quicksort algorithm, and pass it in. Is there a way I can avoid doing that? And that's what we would discuss in the next step, where we would start bringing Spring into the equation. I'm sure this might be a little slow introduction to Spring because we would really want you to understand the concepts behind Spring. The most important concepts behind Spring are dependency injection and loose coupling. And if you understand these two concepts very well, you can make the best use of the Spring framework. And that's the reason why we are giving you an introduction, starting with a simple example. Now we have made it more loosely coupled. We understood what a dependency is. We understood what loose coupling means. We are ready to start using Spring to make this example even better. Until the next step where we will do that, bye bye. Welcome back. This is how our code looks right now. One of the important things that you would already observe is the fact that we are creating objects. So we are creating an object of the algorithm, we are creating an object of the binary search, and we are actually wiring them together. And then we are invoking the binary search. We made the binary search loosely coupled by passing the sort algorithm to use as one of the constructor arguments. It would be great actually if some framework can take control of creation of the beans and the dependencies. What we are looking at on the screen right now is a very simple example, right? So we have one bean and one dependency. But if you look at a typical application, there might be 1000 beans and 3000 dependencies. You would want some framework to manage the beans and the dependencies. What we are calling as a bean is an instance of this object. So this is a bean. So I'm creating a new quicksort algorithm. That's a bean. So we would want to be able to create beans, and we would want to be able to wire in the dependencies. So we would want to be able to create new quicksort algorithm and wire it into the binary search IMPL. That's called wiring. So we would want to be able to create beans, we would want to be able to manage and populate the dependencies. We would want a framework to be able to do that. The Spring framework helps us to manage beans, wire in the dependencies, and do a lot of magic. One of the things we already know is the fact that Spring framework is already in our Maven dependencies. So we already know that the base framework of Spring. So Spring Core is already here, Spring Beans is already here, Spring Context is also here. We are getting these dependencies through something called Spring Boot Starter. Let's not worry about it right now. The most important thing is the fact that Spring is already available for us to use. To be able to make best use of Spring, we would need to tell it three different things. One is, what are the beans? So what are the different beans that Spring has to manage? The second thing that you need to tell it is, what are the dependencies for a bean? Binary search IMPL, if you look at it, the dependency for it is the sort algorithm. So we need to be able to tell Spring that, okay, sort algorithm is a dependency of binary search IMPL. So that's number two. The third thing we need to be able to tell Spring is where to search for beans. Where to search for beans. If let's say you tell Spring that there are certain beans present. So I've told Spring about the beans and the dependencies. It needs to know where to search for them. So should I search in this package, or should I search it in another package? Where should I really search for the beans? These are the three questions we would need to tell Spring about. We need to answer them for Spring so that Spring would be able to help us to wire beans together. So the first thing we need to tell Spring Framework is, what are the different beans? To start off, what we'll do is we'll use bubble sort and the binary search IMPL. So I would want to tell binary search IMPL is a bean. How do I tell that? The way you tell that to Spring is by adding an annotation called @component. @component, control1 or command1, and you would be able to import the @component. I'm telling Spring what are the different components to manage. The other thing I would also want Spring to manage, for now, like I would want to use bubble sort algorithm, so I'll make it a component. Bubble sort algorithm is now managed by Spring as well. The second thing I have to do is, what are the dependencies of the bean? So we created two beans, right? So we said these are the two beans by using the @component. So in @component, I would need to tell Spring that this is a dependency. How do I tell Spring that this is a dependency? The way I would do that is by adding something called @autowired. So this is another annotation which is present in Spring, @autowired. So you can see it in here. So I'm adding an @autowired annotation on the sort algorithm. Now I'm telling that binary search IMPL depends on sort algorithm. Sort algorithm is a dependency for binary search. Bubble sort algorithm does not really have any dependencies, so I don't really need to add auto-wired in here. So the last thing that I need to tell Spring usually is where to search for beans. So if you look at, all our classes are in the same package: com in 28 minutes, Spring basics, Spring in 5 steps. So that's where all our beans are. So the two beans that we have defined are basically the bubble sort algorithm and the binary search IMPL. So we would want Spring to search in this package. So we call that something called component scan. So we would want Spring to do a component scan in this particular package. We are using Spring Boot. Spring Boot would automatically scan the package where the main application class is present. So here, if you look at this Spring Boot application, so this is using an @Spring Boot application annotation. What the @Spring Boot application annotation does is it automatically scans the package and the sub packages of the package where this is in. So Spring in 5 steps application, which package is it in? It's in this specific package. Com in 28 minutes, Spring basic, Spring in 5 steps. So automatically Spring Boot would scan this package and its sub packages for the beans. So there is no need to do this because we are in the same package. First two steps we have completed. What are the beans and what are the dependencies of a bean? That's pretty cool. So now we are saying Spring is going to manage these beans. I don't need to create this. The binary search, we said Spring would create it for us. So we said instead of we doing this creation of code, Spring would do that for us. I would want to be able to get the binary search from Spring. So I would want to get the binary search bean from Spring. How do I do that? The way you can do that is by using the Spring context. This is a line which we already commented. As we said, we are going to create a lot of beans. So Spring Framework is going to create a lot of beans for us. Where are all these beans going to be present? We would create a bean for binary search, we would create a bean for quicksort algorithm, but where would all these be managed? These would all be managed by something called application context. Spring application context is the one which would maintain all the beans. So what we would need to do is we would need to get the bean from the application context. So over here, if you look at it, Spring application.run. So we are running a Spring application in here. I'm importing Spring application. I'm again pressing Control+1. I would want to actually assign this statement to a local variable. The run method actually returns the application context back. So I would want to take the application context and do things with it. So what I'm doing is I'm taking the Spring application.run. It's returning me the application context. And from the application context, I would now want to get the bean. So application context dot get bean. What kind of bean do we want? We would want the bean of the binary search class. So binary search IMPL dot class. I would want to take this and assign it to a local variable called binary search. Take a step back and think about what are all the things that we have done in this step. First, we told Spring what are the beans. How did we do that? At component. Then we told Spring what are the dependencies of the bean. So how did we do that? At auto-wired. These beans are managed by the Spring application context. So we got an application context by running the Spring Boot application class using the Spring application class. This is by default. I mean, if you create a Spring Boot project using start.spring.io, this line is by default present. So what I'm doing is I'm taking that value and assigning it to the application context. So now I have an application context. From the application context, I'm getting the binary search bean. So I'm getting the binary search bean from the application context and executing it. For this specific example, all these things might look complex, but think about an application which has thousands of beans. The fact that you don't need to do this always, and you can directly get the beans from the application context, you can let Spring take care of the dependencies and their wiring. That makes it very easy to manage your applications. We will learn about all that kind of stuff in later steps, but for now let's focus on getting this thing up and running. We'll add a small sysout at the end. So sysout control space system.out.println result, and if we remember things fine, actually we are already printing something in the binary search IMPL, right? So we are actually printing the sort algorithm. So we are printing the sort algorithm out, and also we are actually printing the result out. So what we have done is, instead of creating the instances of binary search and the quicksort algorithm ourselves and wiring them together, we made Spring to wire them together. And we are getting the binary search IMPL bean from Spring, and we are printing the result. Let's see what the result would be. Run as Java application. Okay, console. So if I see this, this is the output which is being printed. So let's copy this output out and see what's being printed. So we see that the component being used is bubble sort. That's cool because that's the one which we said Spring to manage. So we said Spring manage this component, and Spring is able to find that component and wire it in. And we see that the result is being printed 3. What we have done in this step is we made Spring manage our beans. So instead of we creating the bean for binary search, instead of we creating the bean for bubble sort, instead of quicksort, we used bubble sort. And we made Spring to do all the magic and create the beans for us. Spring is managing the beans for us. Spring is managing dependencies. So Spring manages the dependencies, injects the dependencies wherever they are needed, and it manages the entire life cycle of these beans. That's what is called dependency management as far as the beans are concerned. So Spring does dependency management as far as your Java classes, individual beans are concerned. In this step, we learned how to get Spring to manage the dependencies for us. There might be a lot of questions in your mind. Algorithm which is being used is bubble sort. How do I change it to use quicksort? And how can I do that dynamically? And there might be other questions as well. We'll answer those questions in the subsequent steps. Until the next step, bye-bye. Welcome back. In this step, we'll understand what's happening in the background. In the previous step, we added in add component, we added in add autowired, and then we added the code to pick up the bean from the application context and use that to execute the binary search. But what's happening in the background? Let's try and understand it using debug mode. We are using a Spring Boot application. The easiest way to put the application in debug mode, I don't want the entire application to be in debug mode. I just want to put Spring Framework in debug mode. The way you can do that is by using logging.level. You know that the Spring Framework starts with org. So I would want to start with org dot spring frame. Okay, Spring Framework. That's cool. So that alone, I would want to use the debug level. So I'm logging all the log from Spring Framework at debug level. And now I can go ahead and run the application again. Cool. The application has completed running, and you'd see that there is a lot more log than usual. It's a lot of log for you to filter through. So the easiest way to find out what's happening in the background is just take binary search IMPL and keep following the progress of it. So you can start searching Control F and start searching binary search IMPL and keep following the path through it. So what I've done is I've actually done the search, and I've taken important snippets from the log and I have put them in this specific class. The first thing, as we talked about, is component scan. When we talked about creating the beans, we defined the beans, we defined the dependencies, and then we said we have to define where to search for the beans. And because this is a Spring Boot application, we said that this would automatically search in this package. That's called a component scan. So the first thing you'd see is a component scan being run. So it's saying searching this directory. So what I'm doing is searching this directory, which is the directory Spring in 28 minutes, targets, classes, com in 28 minutes, Spring basics, Spring in 5 steps. So that's basically this package. So I'm searching this package for any classes. What Spring does is it starts with a component scan. That's the first thing that Spring runs. Spring needs to know where the beans are. So it goes and searches this package. So it says, I'm searching this package. So I'm trying to find anything which is defined with an add component. One thing you need to remember is add component is not the only annotation that Spring searches for. There are other annotations we'll talk about in future steps. But for now, add component is the thing Spring is looking for.
because that's the only thing which we have used until now. It's searching for classes with add component. So now it says I have found two classes. Which ones? I've found binary search impl.class and bubble sort algorithm.class. These are the two classes which have a component in there. So it's saying identified component class. So Spring is searching. So Spring, what it does, it goes to this package, it searches through all the classes and finds the components. The only two components that we have defined in here are binary search impl that has a add component, bubble sort algorithm that has a add component. The remaining classes we have not put add component on, so they will not be found. So this is an interface, no add component on it. The remaining classes does not have add component on them. That's why they are not found by Spring. Spring only looks for those things which are identified by add component and a couple of other annotations which we'll discuss later. So the two components which are found are binary search impl and bubble sort algorithm. Once Spring has figured out what components it needs to manage, then it would start creating the beans and trying to identify the dependencies. It would start actually, if you look through the log, you can search for binary search impl, you would see something like creating instance of bean binary search impl. So it starts trying to create the binary search impl bean, but it sees, when I try to create the binary search impl bean, it would see that it has a dependency. Okay, to be able to create the binary search impl bean, I would need to actually create the sort algorithm as well. So it goes ahead and sees what else is there. So it goes next, it sees bubble sort algorithm. Bubble sort algorithm, it sees that it does not have any dependencies. So it actually then goes and says, okay, I'll create the instance of it. So it starts creating an instance of the bean bubble sort algorithm. It completes creating it. So bubble sort algorithm bean is ready. Then it sees that binary search impl actually needs bubble sort algorithm. So it says, I would want to wire them together. How does the auto wiring happen? If I open the binary search, I'm opening up the binary search impl class, the auto wiring would take place through the constructor. We have provided a constructor, so Spring would use this constructor to do the auto wiring. So the sort algorithm would be auto wired to binary search impl. That's what you would see in the log as well. It says auto wiring by type via constructor. So this is called constructor injection. In a later step, we'll try and differentiate between constructor injection and setter injection. And once the thing is auto wired, that's it. So the bubble sort algorithm bean is ready, so it can be finished. So the bean is created. So this is how Spring goes and creates all the beans. So whatever you put as add component, whatever you put as add auto wire, it would try to create the components. It would see if there are any dependencies. If there are no dependencies, it goes ahead and creates the bean. If there are dependencies, then it would start searching for those dependencies and try to auto wire them in. Spring does a lot of magic in the background. I would really recommend you to spend some time with the log trying to understand what are all the different things that are happening. In this step, we put application into debug mode and we looked at all the different things which are happening in the background. We got an in-depth understanding into how the beans are managed by Spring, how Spring Framework searches for beans, how it creates the beans, and how it auto wires them. Until next step, bye. Welcome back. In the last step, we tried to understand what's happening in the background. What's happening in the background when we are running a Spring application, how Spring creates beans, how it manages dependencies, and all that kind of fun stuff. We saw that we created an instance of the bubble sort bean. Now, what would happen if I put add component on the quick sort algorithm as well? So now there are two things that are matching. So now there are two components, right? So quick sort algorithm also is a sort algorithm, and also bubble sort algorithm is a sort algorithm. In the previous example, we saw that auto wiring was taking place by type. Sort algorithm. So this was also a sort algorithm. Quick sort also a sort algorithm, and bubble sort also is a sort algorithm. In the earlier example, only bubble sort was having a component. So Spring picks up bubble sort
and it says there's only one component of that type, so it auto wires it in here. What we did now is we added add component on quicksort also, so there are two components on the class path. What does Spring do to resolve that? Let's try that and figure out a lot of variations of this concept. Let's run this application. Failed to start. Binary search IMPL requires a single bean, but actually two were found. So it's saying I need one sort algorithm, but you are giving me two. I can go ahead and remove the add component from the bubble sort algorithm. So I can say, okay, I don't want to use you. I remove that component from it. So what would happen now? Okay, it's using the quicksort algorithm. So that went through fine. Other way you can have done that is by using something called add primary. So now you have two components on the class path. So if you have two components on the class path of the same type, then I can make one of them primary, add primary, and press command 1. You can see that I have bubble sort add component, quicksort add component, and I have added in add primary. Let's see which one is used. Okay, it's using quicksort because quicksort has add primary. If you have more than one component matching a specific type, you can use add primary to give more importance to one of those components. A lot of students getting started with Spring find it difficult to understand what's happening in the background. Since you have a good understanding of it, you would be in good shape to solve any problems that would come up. So let's say what I'll do is I'll remove add component from the bubble sort algorithm. So now both the algorithms, both quicksort and bubble sort, they don't have component on them. So quicksort also we remove the component from. And now let's run the application. The log says application failed to start. So it says binary search IMPL requires a bean of type sort algorithm, but nothing was found for that. So neither the quicksort algorithm nor the bubble sort algorithm had a component on them. So they will not be found by the Spring framework when it searches for components. Or if you are actually, let's say I removed the add component on this as well. So let's go to binary search IMPL and remove add component from here. What would happen? Spring will not find any beans, so it will not create any beans at all. I've removed add component from everywhere. What would happen? It says in main, no such bean exception. So where is the error coming up? You know it. Here we are doing a get bean. We are trying to, from the application context, we are trying to get the bean of class binary search IMPL. But what we did here is we removed the add component for it. Spring will not know about binary search IMPL at all. So Spring is complaining, I have no idea what you are searching for. Go and tell me what you want me to do. So by the errors which it throws, you'd be able to understand what's happening in the background. If I add component, now it says I'm searching for sort algorithm, but I'm unable to find it. You have to make sure that you define an add component in here. So now I can go here and add component, add primary, whatever I would want to add in. And now I can run the application. You would see that it picks up the right one because I put primary on the bubble sort, it picks that up. Whenever you have any problems of the type a bean is not found or multiple beans are found, see if you have used the right combination of add component, add autowired, and add primary. Those are the important things you would need to know to be able to troubleshoot any problem with Spring Framework. So in this step, we looked at add primary and also we looked at a few troubleshooting tips related to solving Spring context issues. Until the next step, bye-bye. In one of the previous steps, we discussed about constructor injection. What we are doing in here is we provided a constructor for the sort algorithm. So the other way you could have done this is by using something called setter injection. So I'm removing the constructor and I'm actually generating a setter. So Alt Shift S or Command Option S or right click, source, generate getters and setters. I just want to generate the setter. So I would want to generate a setter for this. So now you would see that the setter injection would be used. So let's now run this program. I'll be searching for auto wiring by, so how's the auto wiring done? Auto wiring by type from bean name to bean. So it's now using setter injection. Earlier when we did this using constructor injection, this was the line which was in the log. Auto wiring by type from bean name via constructor.
When we are using setter, it just prints auto-wiring by type from bean name binary search IMPL to bean name this. Actually, you even don't need to create a setter. So let's actually remove this setter completely. So I'm just leaving at auto-wired. I'm not even creating a setter in here. Let's run this. Okay, please do save. I'll search for auto-wiring by, and you can see that the text does not really change. So we saw that when we use constructor injection, this is what happens, constructor injection. And when we use setter injection, this is what would happen. And we saw that if we just left at auto with no get setter or constructor, this is what is the log that is being printed. So these are the three options for using auto wiring: constructor, setter, and no setter or constructor. One thing you need to remember is the fact that these two are really the same. So whether you're creating a setter or not, the way Spring does the auto wiring is the same. So when people say setter injection, they would be either referring to any of these. You can even call this to be using setter injection. So if I just put auto wired here and remove the setter, this is kind of also termed to be setter injection, even though there is no setter in there. Basically, we have two options, right? Constructor injection and setter injection. So how do you choose between constructor and setter injection? Actually, the choice used to be really clear earlier. In the earlier versions of Spring, what we used to suggest to do is all mandatory dependencies should be auto-wired using constructor. For example, here, this is a mandatory dependency. Without sort algorithm, the binary search cannot work at all. So this is a mandatory dependency. If there is a dependency which it can work without, so if some dependency is not available and still the class can run, those dependencies are optional dependencies. So if you have mandatory dependencies, then the recommendation was to use constructor injection. For all other dependencies, the recommendation was to use setter injection. So if it's optional dependency, go for setter injection. Otherwise, use constructor injection. That was the recommendation with earlier versions of Spring. But with at auto wired, what happens is, even though you're using setter injection, if a bean of at autowired is not found, so let's say you put at autowired and you don't have any bean of sort algorithm present in the class path, then what would happen? The context will not launch at all. So now actually there is not a lot of difference in terms of mandatory or optional dependencies. Typically in these days, most of the applications I have worked on use this kind of construction. So what this would do is I have no need to create a constructor. However, one drawback of this approach is that you can add a lot of dependencies. So because it's easy to now add a lot of dependencies, what people tend to do is add 5, 10, 15, 20 dependencies for a specific thing, and it would become very complex to manage. The same thing if there was a constructor injection being used, I would need to keep adding stuff to the constructor, and you'd see that the constructor has 15 arguments, which is really tough to maintain. So constructor injection kinds of makes those kind of problems very, very obvious. The setter injection kind of hides those dependencies, because all that you need to do is very simple, right? Create another dependency and just put at autowired on top of it. Other than that, right now, I mean, with the Spring framework as it is, there is not a great deal of difference in using setter and constructor injection. The lines have really, really become thin between constructor and setter injections. Whichever option you pick, I don't think you'd be doing very bad. Until the next video, bye-bye. Welcome back. In this video, we'll discuss about the modularity of the Spring framework. One of the important things about Spring is that it's not one big framework. So what do I mean by that? During the example, when we looked at the modules which were present, so if you look at the Maven dependencies which are present in here, it's not one big Spring jar which is present. There are a lot of small jars which are present: Spring context, Spring AOP, Spring beans. You would see other Spring stuff also right beneath. You can see Spring core in here, Spring JCL, and you also see the Spring test module in here. So Spring is not really one big framework. It's not like you have to use the entire Spring framework or you don't use it at all. Spring is built in a very modular way, and this enables you to use specific modules without using the other modules of Spring. Until now, whatever we have been using is the core container of the Spring framework. We were using Spring Beans, core, and context.
So we were creating an application context. We were using Spring to manage our dependencies, that's beans. These were the core container modules that we were using until now. So until now, whatever we have seen, the examples which we have seen until now are using the core container module. Spring also has very good integration with data and integration layers. What do you mean by a data layer? Data layer is something which talks to a database, right? So I would want to talk to a database and get the data from there. Or I would want to store some data to the database. Or I would want to talk to other systems. So for example, I would want to connect to a web service. Those kind of things are called integration. I would want to probably send a message on a queue. Spring also has good support for those stuff. One of the important data access modules is Spring JDBC, which makes JDBC much more easier. Spring JDBC makes it easier. Something which would take 25 lines of code in JDBC would typically take 5 to 10 lines of code in Spring JDBC. The other thing Spring has is good integration with all ORM frameworks, object relational mapping frameworks. Some of the important object relational mapping frameworks are Hibernate and MyBatis. MyBatis is not really a true ORM framework, but it kinds of has some of the ORM features. Spring has good integration with them through the ORM module, and Spring has good integration with JMS. So you want to talk to some other application over the queue, then through Spring JMS you'd be able to talk to the other application. You can put messages on the queue, and wherever object to XML transformation is needed in those kind of scenarios, Spring OXM provides a lot of useful features. One of the important things with the data access or integration is the transaction management, right? So you would want all the steps in a transaction to be successful, or you would want all of them to be rolled back. So let's say if the transaction involves 4 steps and the third step failed, you'll want to roll back the first 2 steps also. So Spring has great support for transaction management. The other important Spring modules are inside the web space. So Spring has really good connections with web frameworks like Struts. Spring also offers a web framework of its own. It's called Spring MVC. And portlets are kind of outdated. I wouldn't really worry about portlets if I'm developing something right now. Spring has good support for WebSockets also. So we covered the data access layer, we covered the web layer. The focus shifts to cross-cutting stuff. What do you mean by cross-cutting? Typically, when you talk about applications, they have multiple layers. So we looked at things in the web layer, we looked at things in the data layer. There are things which are applicable to more than one layer. Those are called cross-cutting concerns. One of the cross-cutting concerns is unit testing. You would want to be able to unit test things in the web layer, in the business layer, and the data layer as well. Those kind of things are called cross-cutting concerns. So as far as the test framework is concerned, Spring has good support for unit testing through the Spring Test framework. Spring also enables implementation of things like security, logging through aspect-oriented programming. So Spring has a module of its own called Spring AOP to do basic aspect-oriented programming. If you want to do advanced aspect-oriented programming with a framework like AspectJ, Spring provides really good integration with it as well. In this short video, we were looking at the different modules which are offered by the Spring framework. It has solutions for the web layer, it has solutions for business layer, data access layer, and it has solutions for cross-cutting concerns. Until the next step, bye-bye. In the last step, we looked at different Spring modules. All the Spring modules have the same release version as the Spring framework. So they are almost like they are part of the Spring framework. There are other things Spring does other than the Spring framework and its modules. These are called Spring projects. These Spring projects provide solutions for different problems faced by enterprise applications. In this video, let's look at a few of them. Let's start with Spring Boot. Spring Boot is one of the most popular frameworks to develop microservices today. Within a few years, Spring Boot has become the most popular framework used for developing microservices. Spring Boot makes it very easy to develop applications quickly. With features like startup projects, auto configuration, actuator, Spring Boot makes developing applications, especially microservices, a cakewalk.
The other important Spring project is Spring Cloud. We know that the world is moving towards the cloud, right? Everybody wants to deploy their applications in the cloud. And therefore, it's not sufficient if we develop good applications. We have to develop cloud native applications. We would want to be able to dynamically configure applications. We would be able to dynamically connect them. We would want to be able to dynamically deploy applications. Cloud native applications need a lot of different features. So if you have a microservice which is developed using Spring Boot, you can use Spring Cloud to cloud enable the microservice. Spring Data provides a consistent data access. If I go a few years back, there was only one kind of databases that we typically connect to. We would connect to a proper SQL database. Today, there are abundant of NoSQL databases. We have a mix of data sources. So we have we have a wide variety of NoSQL databases. We have SQL databases as well. How do you ensure that the way I'm accessing data from all this stuff is remaining consistent? That's what the Spring Data aims to solve. Spring integration, on the other hand, addresses problems with application integration. There is something called Enterprise Application Integration Patterns. It's a very famous book. Spring integration implements the patterns which are recommended in there. Spring integration helps us in connecting enterprise applications very, very easily. Not all processing is done online. Some of the processing is also done in batch applications. Batch applications have their own requirements. Like, for example, I would want to be able to restart a batch job from where it failed, or I would want to be able to track down exactly what's happening in a batch in much, much more minute detail. Spring Batch provides those kinds of features. It enables developing batch applications very easily. Security is one of the important parts of developing applications. You'd want your applications to be secure, whether you are developing a web application, whether you are developing a REST service, or anything that you develop, you'd want to protect it. So Spring Security provides solutions for securing your applications, whether it's a web application, whether it's a REST service. Spring has support for multiple security, or Spring Security has support for multiple security options like basic authentication, OAuth authentication, OAuth 2 for example. Spring HateOS enables you to develop HateOS compatible services. In REST, it's not sufficient if you just return the data. You'd also want to return the related links that would help the consumer to understand where to go from here. Spring HateOS would help you to do that very easily. What we are looking at are 7 of the Spring projects. They are just touching the tip of the iceberg. There are a lot of other Spring projects like Spring Web Services, Spring Session, Spring Social, Spring Mobile, and Spring Android, which are solving problems in various different spaces. The idea behind this video was just to introduce you to the wide variety of projects in which Spring is involved with. Spring has not really restricted itself to just the Spring framework and got involved in a lot of wide variety of projects. All the stuff you are learning as part of this Spring course would also be useful when you are developing on any of these Spring projects. If any of the projects seem interesting to you, I would really love if you can go ahead and explore it and find things about it. Until the next step, bye-bye. In the last few steps, we discussed about the most important features of Spring Framework. One of the important things about Spring is that it's one of the very few frameworks that remains as popular today as it was 15 years back. 15 years back, I was starting my career as a web developer, and I remember most of the frameworks from those days have lost their context. But Spring is one of the very few frameworks which retains its importance even today. So, what's the reason for this? How did Spring maintain its popularity through these 1.5 decades? That's the subject of this specific video. The most important reason Spring is so popular is because it enables writing testable code. The core feature of Spring is dependency injection, and if we use dependency injection properly, then we would be able to write unit tests for our code very easily. Spring has really good integration with frameworks like JUnit and Mockito, and it enables us to write good unit tests very quickly. The second reason why Spring is so popular, there is no plumbing code at all.
What do you mean by plumbing code? I'll take an example. Look at this example which was done using JDBC. You can see that this is about 20 lines of code. I had to write a lot of code to get simple functionality working. If you look at code, most of it is involved in try catch, in exception handling. Execute method throws a checked exception. So you have to really handle it. And once you have to handle it, then you need to make sure that everything is closed properly. And that's where Spring comes in. With Spring, the amount of code that you need to write becomes almost next to nothing. So if you look at the corresponding method in Spring framework, almost zero exception handling code, because Spring makes all its exceptions unchecked. So you don't really need to do all the exception handling and stuff. This code which you see in here is the plumbing code. So with Spring, you don't have any need to write plumbing code. There is no plumbing code at all. So if I'm writing 100 lines of code, it's most probably some business logic. It's not unnecessary code which is not needed by the application. The other reason why Spring is very popular is the architecture flexibility it brings in. As we looked at in the previous steps, Spring is very modular. There are Spring modules and Spring projects for very specific purposes. And I can use a specific Spring module without using all others. So even though Spring has a really good MVC framework, Spring MVC, it still offers good support to all the other MVC frameworks like struts. Even though Spring has its own REST support through Spring MVC, it does offer good support with Jersey as well. I mean JAX errors as well. If I use Spring in my project, my options are not really restricted. So if I choose to use Spring in my project, I still have the flexibility to choose other frameworks, and that's very important. And the last reason why Spring is very popular is it is able to stay with the trend. For example, in the last few years, there is a lot of evolution with microservices and cloud. And Spring is able to come up with projects which helps it stay relevant. Spring has introduced the new project called Spring Cloud. There is Spring Boot as well, which help you to develop microservices very quickly. So all these things help Spring stay current, and that helps Spring Framework retain its popularity. In this video, we looked at the 4 reasons why Spring remains popular. Because it enables testable code, because it does not have any plumbing code, because of its flexible architecture, and because it stays up with the trends. The idea behind these 10 steps was to give you a big picture overview of the Spring framework. We hope we were successful in doing that. Until the next step, bye-bye.
In 28 Minutes is providing awesome learning experiences to 300,000 learners across platforms like Udemy, Safari Online, and Pact. We have clocked million hours of learning in the last few months. The question is, what do you want to learn next? We are building solutions to help programmers at all levels. You can learn programming with our awesome courses on Java, Python, and JavaScript. You can learn full stack development with REST APIs and microservices with a wide range of frameworks like Spring Boot, Node.js, React, Angular, and Spring Cloud. We have 200 plus videos to help you start your journey from a programmer to a software architect. We have videos to help you learn frameworks, industry trends, including things like microservices. Learn the best practices in architecture, design, and code quality. Thanks for watching. Keep learning in 28 minutes.